we're arguably reaching towards the end of what's called Moore's Law, or the fifth paradigm of computing.
Oh yes, law of accelerating returns.
Yes.
So Moore's Law is one paradigm of many. I mean, Moore's Law says that we're shrinking the size of the key features of integrated circuits, reducing them by a factor of about 100 in 3D volume per decade. It results in a doubling of price performance every year, and it's probably the best known paradigm, but it's not even the first paradigm in computation. It was the fifth.
Yeah.
We had electromechanical devices, and then relays and vacuum tubes and transistors, and then integrated circuits.
So let me read the question here that Larry Greenblatt asks. And he says, this is the same question I've been trying to get answered since Abundance 360, where you were joining us in the last few years, and thank you for that, Ray. He says, what does Ray see shaping up the sixth paradigm? Is it still three-dimensional computing, or have you become warmer to quantum computing or something else? So what's coming after
we hit the... Well, not quantum computing. I mean, we can talk about that.
We will.
That wouldn't even accelerate. Most algorithms can't really be parallelizable in that way. But and we're very far from practical quantum computing. Yes, we've already started going in the third dimension. Moore's Law has already substantially slowed down. This shrinking of the key feature sizes of transistors on an integrated circuit has substantially slowed. The law of accelerating returns has not slowed at all. I mean, I have these graphs. We're still doubling price performance each year, and it's not coming anymore from Moore's Law. It's coming from increasingly using the third dimension.
I know that Western Digital, that owns SanDisk, has put out a 96-layer, multi-layer chip.
Yeah, so we're moving in that direction. I think by the 2030s, we'll actually go back to mechanical computing, which is where we started in the 19th century with
explain that. I remember the first
analytic engine.
I remember the first time I was when I was at undergrad at MIT. Eric Drexler, who wrote the Engines of Creation, was a grad student there, and he sat down and showed me what a mechanical computer inside a cell might look like in the future.
Yeah, well, if you're going to develop the ultimate in computation, which we call computronium, getting the most computation you can get based on the laws of physics at the atomic level, it would be mechanical. And I think we'll actually get there based on the research that's happening now by the 2030s. And that will result in